The Decorator Design Pattern is a structural pattern that lets you add additional functionalities to classes dynamically, and it circumvents extensive subclassing. Now, what is the actual problem the design pattern is trying to solve? Well, subclassing is static, and it can get very messy quickly when many different feature combinations are needed. So an example, we're a car manufacturer. There are different types of cars with different functionalities. Initially, we have a basic car, a sports car, a cabrio car, and a self-driving car. After a while, customers ask us if we could get them a sports cabrio car or a self-driving cabrio car. Of course, these are new combinations of the functionalities we already offered. So we decide, okay, sure, we can do that. We just have to represent those with new classes in our system also, right? The more features we offer, the more possible combinations of functionalities there are, and thus we need more and more new subclasses. Unfortunately, with this approach, we're very limited. Imagine we had another basic car type here, an SUV. Our class hierarchy would just explode with the additional combinations here. So we need another approach to offer our customers absolute freedom of customization of features. The solution is to add functionality dynamically by using recursive composition to allow an unlimited number of decorator layers on top of a basic object. So a basic car in our case. Sounds like a mouthful. Let's have a look at the UML diagram to understand how we want to achieve this. So we're going to have an interface basic car that gives us the methods drive and park. We have a basic car class that implements the interface. We have an abstract car decorator class that implements the interface and uses composition, so contains a basic car inside of it. And then we have specific decorator classes that extend the abstract car decorator and offer the additional functionalities like lower roof, broom, AI. Okay, now let's have a look at the code to see how this works. So step 1, create the interface. We have the empty methods drive and park that need to be implemented later on by classes that use the interface. Then the basic car is implementing those two methods simply by printing out car is driving and car is parking. Then we're creating the abstract decorator class. So again, here we can see that we're using composition. We use a basic car here inside of the car decorator class. And then again, here to implement the drive and park method, we're using that basic car and we use that basic car's method drive and park. Okay, so that's the basic two elements. We have a basic class that we want to decorate, and we have the abstract class decorator that can be extended by actual decorator classes. Okay, one of those decorator classes is the cabrio car. It extends the car decorator, so it also assigns a basic car inside of it. It's also implementing the drive and park methods, but additionally it offers the lower roof and mount roof functionality, which is called inside the drive method and the park method. So whenever we start driving, we're lowering the roof, and whenever we park, we also mount the roof again. Okay, then we have the next decorator class, self-driving car. Again, it's very similar. We assign a basic car inside of it. We have drive and park, and as an additional functionality, we just have AI happening, so it's happening autonomously. The car is driving itself, driving and parking itself. And then the last one we have is sports car. Same again, same functions, composition, plus the function broom, so we're making some noise and people look around when we drive and park. And that's already it. We didn't have to create crazy subclassing hierarchies. We can just use that basic car and the decorator, and we create as many decorator classes as we want and add them on top of each other. We're creating a basic car, let it drive and park. We're creating a cabrio, let it drive and park. We're creating a self-driving cabrio to let it drive and park. And then finally we create the ultimate combination, the self-driving sport cabrio, and also let it drive and park. So let's see what this does. Okay, seems to work. So a basic car is driving and parking, seems to be right. The cabrio is driving and lowering the roof, okay. And it's parking and mounting the roof. Perfect. Self-driving cabrio. We have the car is driving, it's happening autonomously, and it's lowering the roof. Perfect. Car is parking, it's happening autonomously, mounting the roof. Great. And then finally, the ultimate combination is also additionally doing some noise, and people turn their head. Okay, seems to work. And all we have to do is we take a basic car and then we wrap it in those decorator classes, which add the additional functionality. Just to see how convenient the decorator design pattern is, we have a look at the classic approach with the subclassing to achieve the same thing. So to do that, we would create a basic car class with the drive and park methods. They're already implemented here. Then we would extend that class with the cabrio car, self-driving car, and the sports car. We extend the basic car and we add the additional functionality here. And then to add additional functionality on top of that, for example, like the self-driving cabrio, because Java doesn't allow multiple inheritance, we're going to extend one of the two classes we want to inherit from. We're going to inherit from that, and then we get the other part of the functionality by using composition. So we create another object inside of it, and we use that functionality then from that object. So in that case, we extend the cabrio car, we get the cabrio functionality from inheriting it, and then we get the smartness from creating a self-driving car inside of the self-driving cabrio. And we have to do the same thing here for the other ones, same style. So we can see the instantiation is already more complicated, and we have to create many more classes than with the design pattern. Also, again, as I mentioned, if we had another SUV type, this would get even more extensive. And here, just to run it, we would just create those pre-made classes and call the functions, and that would result in the same thing.